demonstration of reflection. Demonstration of reflection. So once again, to demonstrate, you need ripple tank. You are going to demonstrate reflection using a ripple tank. So from now onwards, I will not draw the 3D ripple tank. So you know how it's going to look like. So to save time, I will draw the side view of the ripple tank, the side view, right? So not the 3D figure, the 2D figure, right? Okay, so the ripple tank is going to look like very close to this time. Right, these are water surface. So obviously, for you to observe, like for you to demonstrate reflection, what is the condition? What is the factor that you need? You need an obstacle. Then only the water wave is going to reflect. Okay? Need an obstacle. Now, let's place the obstacle. Obstacle. Right. So let us use, first of all, right? Let's use a point vibrator. Let's use a point vibrator, right? Let us use a point vibrator. So now if this point vibrator is vibrated or oscillated up and down on the water surface, what happens? A water wave will start to propagate and it will meet with this obstacle and it will reflect. But can you see the reflection based on the water wave? Yes, slightly you can observe that. It's like you can see when you make a small when you drop a small piece of stone inside a well, it creates ripples. Those ripples goes and collides with the wall and it returns back slightly. Right? You won't be able to 100% see that, but if you observe in detail, you'll slightly be able, like that is not what is expected. You need to be 100%. You need to be able to observe it. So you can observe that. You can observe the reflection. You can observe the reflection on the screen. You can observe the reflection on the screen. I will draw the top view of the screen. I will draw the top view of the screen. So this is the point vibrator. So this is the obstacle. This is the obstacle. Now it's the top view, right? So you are seeing from the top. When you observe from the top, this is how it's going to look like. So the wave fronts are going to move. How exactly? So it's moving this way. So the next wave collides. You know, when it collides, it's going to have a phase change. Turns the other side and returns back. So the phase change and all can't be observed, but you can observe the change of direction, reverse direction. That is, the reflected wave is going to look like this. Reflected wave will reach back in this direction. Reflected wave will reach back in this direction. These red color waves are what? This red color waves are reflected wavefronts. What are these blue color waves? Incident wavefronts. Incident wavefronts, and the wave fronts which are traveling backwards is the reflected wave fronts. Reflected wave fronts. If you now use, if you use a rod, if you use a rod, if you use a rod, what happens? A plain rod. You use a plain rod, what happens is the same way the wave will move forward, but when it looks like, it's going to look like this. It's going to look like this, right? So here, of course, right, this is how the obstacle is going to be, right? This is how the obstacle is going to be, right? So when you create a wave, for example, if this is the incident wave, so wavefronts of plane rods, wavefronts of plane rods are going to be straight lines, right? This is the top view, straight lines. It's going to move this way, right? Okay, it moves in this way, and when it collides or meets with the obstacle, right? What might happen? What might happen when it collides with the obstacle? When it collides with the obstacle, it will return back in this way. It will return back. So fine, right? So you have observed the reflection. You have observed the reflection. It's fine, right? Is that the case? Can you observe this? Can you observe this kind of a reflection by using the ripple tank? I mean, will it make sense? Is it going to be blue in color, the incident ray blue in color and the reflected ray red in color? No. Everything is going to look like the same. You won't be able to observe the incident and the reflective rays. You cannot observe the incident wavefronts and the reflected wavefronts distinguishedly. Like it's going to look like the same thing. So although I have drawn it in blue and red color, you are not going to observe that in blue and red color separately. Everything is going to look like the same. So to avoid this and to distinctly observe this incident rays and the refractive rays, reflected rays, to distinctly observe this incident wavefronts and the refractive wavefronts, right? The incident and the refractive wavefronts, reflective. To distinctly observe this, what you do is simply you just, this is the top view, you just incline this. You just incline this. You just incline the obstacle. You just incline the obstacle. when that is inclined, right? When that is inclined, when this is inclined, what happens is, let's draw the inclined figure. When this is inclined, what happens is, let's assume this is the like in this case of all, this is the incident ray, and on the same line, the refractive ray also falls. It's kind of difficult to distinguish. Here, what happens is, this is the refractive ray. This is the refractive ray. So what will be the normal to this obstacle surface? The normal to this obstacle surface is this. So you know how reflection takes place when you consider a mirror. When you consider a mirror, when a light ray falls onto the mirror, you might have done these things in O levels, right? So when a light ray falls onto the mirror, right? So if this is the normal, this is the angle theta, it will make the same angle theta and reflect. So make the same angle and reflect. Light is also a wave. Water wave is also a wave. Same thing, pretty much the same thing occurs. The lights, this is theta angle, it makes the same theta angle, and this is the ray. This is the ray. So therefore, the wave fronts are going to be perpendicular to the ray. Wave fronts are going to be perpendicular to the ray. Obviously, we know that, right? So this is pretty obvious. You can distinctly observe this observation. Right? You can observe this pretty well. The reflection. Right? You can observe this reflection pretty well, right? So this is going to be the incident wave fronts, right? You see the wave fronts, and these are going to be the reflected wave fronts. Reflected wave fronts, right? Okay. Right. So this is it for the complete reflection once again in water waves, because in water wave reflections there's nothing much to discuss except for the ripple tank, right? So except for the ripple tank, there's nothing much to talk about in reflection in water waves, right? So that is it for the reflection in water waves, right? Okay. This and this you need to be able to draw these things, right? They might give you this only, and you need to draw the ray and the normal, get an equal angle to the normal, and draw the ray, and then draw the wave fronts, right? So there was a specific question. I can't remember whether it's an experiment or it's a essay, but in a certain year they gave only this forward wave fronts. There was a obstacle which was placed inclined. So, and then they ask you to draw the reflected wave fronts. So you need to draw it properly according to a certain concept, right? So you need to draw this ray first, draw the normal next. So check the angle between the normal and the ray. Draw, like, take an equal angle, draw the reflected ray, right? Draw the reflected ray, and always the wave fronts are going to be perpendicular to the ray, right? So it's perpendicular to the ray. Hope you understood that, right? So that's how it's going to be. That is how it's going to be, right? Okay.